To use cloning or parallel printing on Hyrel printers, we need to calculate what percentage of the overall extrusion width each extruder is going to contribute. For simple blending with the static mixing head or dynamic mixing head, you're just going to select the percentages you want. So for example, if you want the head on the left to contribute 20%, you would make the feed rate multiplier 0.2. And if you wanted the other extruder on the right to do 80%, you would do 0.8. Then you would right click up here in the black area next to the temperature and do flash head settings to store these values on the extruder. It's really best if you use your material flow rate multipliers here and leave your pulses per microliter alone, because those are set for the extruder that you're using. However, if you're going to do coaxial extrusion, we need to calculate the percentage of the extrusion that each nozzle is going to provide, each extruder. In our example today, we're going to use an overall nozzle diameter of 3 millimeters and a core cross-section or diameter of 1.5 millimeters. Okay. What we're going to do is we're going to take the overall diameter, in this case 3 millimeters, and divide it proportionally so each of the heads knows how much of the extrusion is inner material and outer material. If the inner diameter or the diameter for the core is 1.5 millimeters, then the inner extrusion area is 1.77 square millimeters. That's the core. If the outer diameter is 3 millimeters, the overall area is 7.07 square millimeters. If we subtract the 1.77 core from the 7.07 overall, we get 5.3. So the area for the shell material is 5.3 square millimeters. Now 5.3 is 3/4 of 7.07, so the outer material should have a flow multiplier of 0.75 for a 3 millimeter nozzle. And then the inner, or the core, is 1.77. That's 1/4 of 7.07, so the inner material should have a flow multiplier of 0.25 for a 3 millimeter nozzle. Now with our typical setup, we have the core on the left and the shell on the right. So we're going to set the core to 0.25, and then we're going to flash that to the head, and we're going to give the shell 0.75, and then we're going to flash that to the head. Now remember, you need to do your cloning either through the GUI or through the stipulated in your G code. That's all explained on the wiki. You do want to remember that cloning heads or parallel printing does not work if you're using M229E1D1 in your header. That's the command that tells us to use the E values generated by the slicer. So you must use M229E0D0 to let us do the flow calculations based on what we said here the nozzle and layer sizes are.
See that cross section right there? There's an inside white layer inside of the orange layer. That's how the coaxial prints. So here's a cross-sectional view of the final result of the coaxial print. It's not perfect because it's RTV, but you can see there's an inside layer of clear inside of that orange layer. There's where I cut open. You can see that running through.